Welcome students. Today we are discuss the unit number 5, 8085 interrupt. Student will be able to learn the following objective from this lecture. What is an interrupt? Types of interrupt, polling interrupt, interrupt driven IO, classification of interrupt, vector interrupt, RIM and SIM. What is interrupt? So interrupt are the signal generated by the external device to request the microprocessor to perform a particular task. And there are 5 interrupt signals are there. Trap, RST 7.5, RST 6.5, RST 5.5 and INTR. There are two types of interrupts, pulling interrupt and interrupt driven IO. So now we have discussed the pulling interrupt. So in a pulling interrupt, okay, the microprocessor is asked to the each and every device for the data transfer request. So in a pulling method, the microprocessor asks each device in a sequence whether it is ready for the communication. If the device is not ready for the communication, the microprocessor asks to the next device in chain. When microprocessor reach to the last device, the same processor are repeated and starting from the first device. The main drawback of this polling method is that the most of time our microprocessor is remain busy. Now second method is interrupt driven IO method. So in this method, the microprocessor is not continuously scan the all the device, but whenever our IO device are ready to send the data, so IO device are send the request to the microprocessor, and then microprocessor is communicate with the that device to transfer the data. So in this method, the device is send the request to the microprocessor. Whenever the device is transfer the data with microprocessor, the advantage of this system is microprocessor is not remain busy all the time. The following step to be performed by the microprocessor whenever the interrupt is occurs. The first step is it complete the current instructions and suspend the current program. Save the address of the next instruction on the stack. Jump to the special routine known as the interrupt service routine ISR, which perform the necessary data transfer. Resume the suspended program by the getting its address from the stack. Classification of interrupt. We can divide the interrupt in mainly two types: software interrupt and hardware interrupt. The software interrupt is occurs due to the execution of special instructions and supported by the microprocessor. For example, reset. Classification of interrupt. So the interrupt is mainly classified in two category: hardware interrupt and software interrupt. Hardware interrupt is again classified two category: maskable and non-maskable. Maskable interrupt means we can control it, we can stop it. Okay, and non-maskable means we can't control it whenever it is occurs. So maskable interrupt is RST 7.5, 6.5, 5.5, INTR. So all are maskables. And trap is a non-maskable. The hardware interrupt is caused by sending the signal on the one of the interrupt pins of the microprocessor. The 8085 support the 5 interrupt: trap, RST 7.5, 6.5, okay, 5.5 and INTR. The hardware interrupt are also classified into the two types: maskable and non-maskable. The maskable interrupt are disabled by the microprocessor, and non-maskable interrupt cannot be disabled. The trap is a non-maskable interrupt and other are maskable. Maskable interrupt controlled by EI means enable interrupt and DI disable interrupt instructions. Vector interrupts. So vector interrupt means those vector has vector location or address is fixed as shown in block diagram. RST 7.5, 6.5, RST 4.5 and trap has vector interrupt and INTR is a non-vector interrupt. So as shown in block diagram, RST 7.5 has the vector address is fixed, that is 003CH. So whenever the RST 7.5 interrupt is occurs, microprocessor transfer its control at the 003CH, and the ISR is mentioned over there. So a microprocessor is execute that ISR. Same like that, RST 6.5, the vector address is 0034 H. So whenever the RST 6.5 is occurs, microprocessor transfer its control at 0034H, and RST 7.5, 6.5, 5.5 are maskable, and TRAP is a non-maskable. As well as RST 7.5 is a age trigger interrupt, RST 6.5 is a level trigger, RST 5.5 is level trigger. TRAP is both age as well as level trigger, and the INTR has no vector address. So whenever the external hardware is interface with the INTR interrupt, okay, so that address is mentioned by the external hardware, and the INTR is a level trigger interrupt. And RST 7.5, 6.5, 5.5, and INTR are maskable. So maskable bit is used to control the our maskable interrupt, and the trap is a non-maskable interrupt. So we can't control it when it is occurs. Vector interrupt are those which have fixed vector address, starting address of the subroutine, and after executing this program, control is transferred to that address. Non-vector interrupt are those in which vector address is not predefined. The interrupting the device is give the address of the subroutine for these interrupts. INTR is only non-vector interrupt in 8085 microprocessor. Format of SIM set interrupt mask. It is used to implement the hardware interrupts like RST 7.5, 6.5, RST 5.5 by setting the various bit to from the mask or generate the output data via the serial output data lines. The first the required the value is loaded in accumulator, then the SIM will be take the bit from accumulator. This is a pattern for or format for SIM. So it is consists total 8 bit. So RST 5.5, 6.5, 7.5 is respectively D0, D1 and D2 bit. The D3 bit is MSE, mask set enable. D4 is a additional control for RST 7.5. D5 is a don't care. D6 is a serial data enable, and D7 is a serial output data. Bit 0 is a mask for RST 5.5. Bit 1 is a mask for RST 6.5. Bit 2 is a mask for RST 7.5. If the mask is 0, then interrupt is available. If the mask bit is 1, then interrupt is masked. Bit 3 is mask set enable. MSC bit is the enable for setting the mask. If it is 0, then mask is ignored and the old setting is remain as it is. If it is set to 1, new setting is applied. Bit 4 of the accumulator in a SIM instruction is allow the resetting the RST 7.5. Okay, so bit 4 is an additional control for RST 7.5. Bit 5 is a not used for the same instruction, so that's why it is not don't care. Bit 6 and bit 7 is used for extra functionality such as serial data transmission. Set interrupt mask so that RST 5.5 is enabled and RST 6.5 is masked and RST 7.5 is enabled. Format of RIM, read interrupt mask. So this instruction is used to read the status of the hardware interrupt RST 7.5, 6.5, RST 5.5 by loading into the register A. Format of RIM, read interrupt mask. This instruction is used to read the status of hardware interrupt like RST 7.5, 6.5, 5.5 by loading into the register A byte which defines the condition of the mask bit for the interrupts. It also reads the condition of SID serial input data bit on the microprocessor and showing the status of each interrupt pin and mask. As shown in figure, this is a format for the RIM, and first 3 bit RST 5.5, 6.5, 7.5 are for it is maskable or non-maskable. Then I is interrupt enable. Then RST 5.5, 6.5 and 7.5 are show the status of whether it is pending or not, and SID serial data in. So bit 0 to 0, 1 and 2 show the current setting of the mask for each RST 7.5, 6.5, RST 5.5. They are written the content of 3 mask flip-flop. Bit 3 show the whether the mask able to interrupt process is enabled or not. It can be used a program to determine the whether or not interrupt are enabled. Bit 4 and 6 show the whether or not there are pending interrupt on a RST 7.5, 6.5 and 5.5. Bit 7 is used for the serial data input. The RAM instruction is read the value of the SID pin on the microprocessor and return it into this bit. Microprocessor can be interrupted again before the completion of the ISR. As soon as the first interrupt is arrives, all the masks able to interrupt are disabled. They will be only enabled after the execution of EI instructions. If the EI instruction is placed early in the ISR, the other interrupt may be occurs before the ISR is done. Thank you.